Hi everyone, in today's video we're going to talk through how we go about solving equations with variables on both sides of the equal sign. So a lot of the things that we've been doing to solve equations are still going to apply here. We've just complicated things a little bit by putting variables on both sides. So let's start with number one. This is kind of the most basic example of a problem that we might have. So if I notice, I'm going to look at the left side. The first thing I notice is there's no combining and no distributing to be done. So I'm going to look on this side here, and it's the same thing. I don't have any combining or distributing to be done, so I'm going to start now by moving my constants and my variables. Now, when I have a problem like this, the first thing I always do is move my variables. And I like to move my variables to the left side of the equal sign. So in other words, I want all my variables to be over here, and I want all my constants, remember the constants are just the numbers by themselves, I want those to be on the right-hand side. So the first thing that I'm going to do is I'm going to take this 4x and I'm going to move it to the left side by subtracting 4x. So when I go to simplify this, I'm going to bring down the 7. I have a negative 8 minus 4, which is going to give me a minus 12x. On this side, my variables canceled out, and all I have is negative 17. So far I've been successful in getting all my variables on the left side. Now I just have to move this constant over to the right-hand side. So I'm going to subtract 7 on both sides, and I get negative 12x. Here I need to be careful with my signs. I have a negative 17 minus 7, which gives me a negative 24. And now to finish this off, I'm going to divide both sides by negative 12, so that my answer here is x equals positive 2. Now, I chose to move my variables to the left side, but I want to show you, I'm going to show this another way. It actually does not matter which side we move our variables to. So if I were to do this problem again, let's say this time I want my variables on the right side and my constants on the left. And let's see how we would do that. So this time, since I want my variables on the right, I know that this negative 8x I want to move over. So I'm going to use the inverse of subtraction, which is addition, and I'm going to add 8x to both sides. So now my x terms are going to cancel. My 7 comes down. On this side now I have an 8 plus 4, so I have a positive 12x minus 17. Now, I want to move this constant over here. So again, we use our inverse operations. The inverse of subtraction is addition, so I'm going to add 17 to both sides. So this is going to cancel. I'm left with 12x on this side. My 17 plus 7 is a positive 24. And so now to get x by itself, I divide by 12. And I still get x is equal to 2. So it doesn't matter which side you put the variables on. It'll largely become a matter of just kind of preference, or like we'll look at number 2, sometimes it may make more sense to move the variable to one side or the other. So let's look at number 2. When I'm looking at number 2, I notice that on the right side, the variable is actually the only thing on that side. So in my mind, I would think it would make sense to move all my variables over here and leave my constant alone on this side. So in this case, it actually makes sense to move my variables to the right. So now to move my negative 3m over, I'm going to use my inverse operations. The inverse of subtraction is addition. So I'm going to add 3m to both sides. These terms will cancel, and I get 24 is equal to 5 plus 3 is 8m. Now to finish this off, I'm going to divide on both sides by 8, and I get m is equal to a positive 3. All right, we'll do one more together. Let's look at number 3. Now, as I'm looking at number 3, if I start on the left side, I know there's no combining to be done and no distributing. However, on the right side, I have those parentheses which tell me I need to distribute. So that's where I'm going to start this problem. Before I do anything, I'm going to copy this down because there's nothing really to be done here. But before I do anything else, I'm going to go ahead and distribute on the right side. So when we're distributing, we're using multiplication. So 2 times 3 gives me a positive 6z. 2 times a negative 4 is a negative 8. And now I just have my regular equation with variables on both sides. I like to move my variables to the left. So I'm going to put my variables here and my constants on this side, which means the first thing I'm going to do is take this variable and move it over to the other side. So I'm going to subtract 6z from both sides. Now I have 5 minus 6, which gives me a negative 1z. Again, I don't write the 1 as the coefficient because it's implied. If you have that there, that's okay. I'm going to bring down my minus 2. Over here, my z's canceled, and I have a minus 8. Now we're back to those two-step equations that we did before. First thing I'm going to do is move this constant. So I'm going to add 2. So I have a negative z. I know negative 8 plus 2 is a negative 6. Now, it may seem like we're done, but we have to remember that really what we have in front here is a negative 1. So to get z all by itself, we need to divide by that negative 1 on both sides. When we do that, we get z equals a positive 6. So we'll leave examples 4 and 5 for class so we can kind of work through those together. And let's go ahead on to the next page. All right. Now, so far, the equations that we've worked with have been of this type. They have only one answer, which means there is only one value that makes the equation true. Okay, so a problem may look like this. Again, here's another example where we have variables on both sides. I'm going to move my variables to the left and my constants to the right. First thing I'm going to do is move this 2x by subtracting. So 3x minus 2x is 1x minus 5. On my right-hand side, I have just a positive 7 left. So now to get x by itself, to isolate x, I'm going to add 5 to both sides. And I get x equals 12. So that's what we mean by one solution. This means 12 is the only value of x that makes the equation true. So it's the only value that if I substituted it for x would make those two sides of the equation equal. We could have, however, a couple other different situations happen. Sometimes we get infinitely many solutions, which means that some equations have many, many correct answers, right? So instead of only being one value that makes it true, there are an infinite number of values that make the equation true. So let's take a look and see how we would recognize this. If I have an equation here, I notice on the left side, I can't do anything with that yet, but I have parentheses over here which tell me to distribute. When I do that, I notice that both sides of the equation are exactly the same. When that happens, when we notice that both sides of the equation are exactly the same, we say that equation has infinitely many solutions. Because no matter what we plug in for x, we're always going to get the same value on both sides of the equal sign because they're exactly the same. Now, the third thing that could happen is that we could get actually no solution. So this is an equation that has no answers. So there are no values that make the equation true. And here's how we would recognize it. So again, we may not be able to immediately tell, but when we go to solve our equation, this is 3x. I know I have to distribute on this side. So I get 3x, and then 3 times 4 is a positive 12. Now, if I decide to move my variables over and I subtract 3x on both sides, this would give me 0, but I'd be left with 12 over here. And we know 0 is not equal to 12. And so then we would say that that has no solution, because there's no value of the variable that's ever going to make this equation true. Okay, so that's everything you need for today. Tomorrow in class, we'll go over those extra examples, and then you'll have the class period to practice these equations. Have a great weekend, and I'll see you on Monday.